Really, I can't hear you. Like, I listened to the one from...
So if I scream right now, you wouldn't hear me.
If you scream, I'll hear you.
Okay.
But you might not hear this conversation. But if you press the link, you can find out. All right. Okay. So, how do you know when an equation's quadratic? I ask you all the time, look at this equation. What type of equation is it? What does it have if it's quadratic? Ken? X squared. So, x squared, I'm going to say is the highest power of x. And the reason I say is the highest power of x is because you could have an x squared, and if you had an x cubed, it wouldn't be quadratic anymore, and then it goes up to a cubic. So x squared is the highest power of x. So we've looked at that a lot. I've asked you over and over, what type of equation is this? If it had an x squared, hopefully you realized it was quadratic. So using the methods of factoring, from 6.6, we want to solve x squared minus 25 equals 0. So the first thing you need to solve by factoring has to be equal to 0. All right, we've got that. And then x squared minus 25. How would I factor x squared minus 25? X minus 5, x plus 5. So that's our difference of two perfect squares there. So we're going, oops, I'm in the wrong one. Here we go. X minus 5, x plus 5 equals 0. And then from there I can get my two answers. I just take each factor individually and set it equal to 0. So we did this back in Unit 1. And then I'm going to get two answers from there. From my first factor, I get positive 5. From my second factor, I'm going to get negative 5. So I have x equals positive 5 and a negative 5. Two answers. Quadratics can have up to two answers. Now, what we're going to do is we're going to solve that same equation, but we're going to use a different method. And this method is called the square root property. So the square root property, part of what's important in Unit 4 is keeping straight all of the setups. Now, there's really only two setups, equal to 0 or equal to a constant. And this is an equal to a constant setup. So I'm missing the equals on here. So if you have a squared equal to b, and b is a real number, then a equals plus or minus the square root of b. So if you have something squared and it's equal to b, which is just a number, you have a equals plus or minus the square root of b. So to solve the square root property, we need that first setup, a squared equals b, where b is my number. So the first thing I'd have to do is move the 25 over if I want to match that setup. So I have x squared equals 25. That's my setup for the square root property. A squared equals b. B is a number. And then think back to 10.6. So in 10.6, we had equations that had square roots in them. And how did I undo a square root? Squared it. So squaring and square rooting, we learned undid each other. We saw that in 10.6. So this time, I'm starting with the squared. I'm going to have to square root it. So we're essentially doing backwards of what we did in 10.6. So to get rid of the squared, I can use the square root. So if I take the square root of x squared, what's the square root of x squared? X, which is what I'm solving for. So that's handy. And if I take the square root of the left side, to keep this balanced, you got to take the square root of the right side. But there's one other thing that we need other than just the square root. Plus or minus. So notice, we have to account for both the positive and negative root here, because we don't know what x is. You might never have paid attention to it, but the directions in your problems in Chapter 10 said assume x is a positive number. We don't have that assumption anymore. So if we want to get both of our answers here, you have to account for both the principal and negative root. You have to use that plus or minus. So when I simplify the square root of 25, I get x equals plus or minus 5. What that plus or minus means is when you break it up, you get positive 5 and negative 5, which are the two answers that we got when we solved the same problem by factoring. But if you leave the plus or minus off, then you're just going to get 5, and 5 is only half of the answer. And I always like to say, you give me half the answer, I give you half the points. So you've got to include, when you're using the square root property, you've got to remember that plus or minus. And if you think you're going to be prone to forget it, one way to kind of make yourself remember it is when you get to the end, always break that plus or minus answer up. If you're not coming up with two answers, then you missed something. The only time I can think that your square root property is only going to have one answer is if it's 0. Ken? There's certain I'm saying I would suggest if you think you're going to forget the plus or minus, don't. There are certain cases which we'll talk about when you can't leave the plus or minus, but in most cases you can leave plus or minus 5. We'll talk about in the next section, or on this section, I guess, where you can. So plus or minus 5, or if you break it up, you have a positive 5 and a negative 5. So in this section, in Unit 4, there's going to be, again, several different methods for solving quadratics. And on some problems, the directions will specify. It'll say solve using the square root property or solve using the quadratic formula. And if you don't use that method, even if you get the right answer, you don't get any points. There are other problems that are just going to say solve. And it's going to be completely up to you which method you use. Now, there are certain methods that work for all of them. This is not one of them. This doesn't work for every problem. But this is a nice quick method for some problems. So my question is, how do you know when to use the square root method, square root property, if the directions don't specify to do so? What you're looking for in your problem is you always want the setup, or easy to get to the setup of something squared, and that's purposely vague. So just something squared equal to a number. And this side here is just a number. It can't have any x's with it. Now, the something squared, it could be a monomial, so like x squared, or it could be a binomial. We'll see some of those coming up here. But the right side can be just a number. So what you're really looking for, if you have x squared, so if you have no parentheses, you cannot also have the term that has x on it. It's just the x squared, just the number, or just a binomial squared and a number, nothing else. But it is a quick method if you've got that set up. So what we're going to do is we're going to solve quadratics using our square root property. First thing you have to do is you have to isolate the squared term. So it can't have a coefficient other than 1. There can be nothing added or subtracted. If it's a binomial, it's okay to have something in the parentheses, but you can't have anything outside of the parentheses. Then we're going to take the square root of both sides. Squaring and square rooting, we saw in 10.6, cancel each other out. And when you take the square root, make sure you account for the positive and negative root. That's using your plus or minus. Then we'll talk about how to solve from there. And the last step, this is where you're not allowed to leave the plus or minus. If you simplify your answer and you get something like 2 plus or minus 5, so there's no square root left in this answer, that's a case where you have to break it up, or I will take points off, because you can simplify that further. Because what the plus or minus means is the first time you do 2 plus 5, that's the plus, or the answer 2 minus 5. So there's 2 answers there. You do one first taking the plus sign, and then the second answer taking the minus sign. And you can simplify that. You can tell me what 2 plus 5 is. You can tell me what 2 minus 5 is. They both work. They'll both work. So that's the only time I make you separate it. I'm going to separate it on all of them just to get in the habit to make sure that you're including your plus or minuses. So our directions. Solve each equation by the square root property. If possible, simplify radicals or rationalize denominators. Express imaginary solutions in the form a plus bi. So there's a lot of Unit 3 in here. We still have to simplify every radical. If we get the imaginary answers, we need to make sure we have a plus bi. And then also today we're going back to Unit 1 and we're going to be factoring. So Unit 4 brings a lot of our old topics back in. So my first problem says x squared equals 36. So this is a prime candidate for the square root property. The directions say so we have to use it. But something squared, that's x squared. And on the right side is just a number. It's the only time the square root property applies. So if I have x squared and I'm solving for x, what's the opposite of squaring? Square root. So if I take the square root of x squared, I'm going to be able to get down to my x. But if I take the square root of the left side, I've got to take the square root of the right side, accounting for both the principal and negative root. So we weren't told to assume anything about x. So the squaring and square rooting on the left side, just like in 10.6, cancel each other out. So we get x equals plus or minus 6, square root of 36. So my two answers, if you wanted to see your two answers separated, one is the positive 6 and one is the negative 6. And if you're not coming up with two answers, you're likely missing something. It's usually that plus or minus there. If you can't tell me two separate answers to this quadratic, again, unless it's 0 for the square root property, you should have your two answers. This one in particular looks a little bit like when we solved the perfect squares and we got the plus or minus. The rest of them aren't going to. But yes, this one you could, another perfectly fine option would be to solve it by factoring.
And it'll work out just the same?
This one will. The others won't. Well, well, we can't see it quite yet in this one. The only reason it works here is because 36 is a perfect square.
Yeah, so if you have any perfect squares, just a 1, you'd be able to factor it.
If you have a perfect square and you're missing the middle term, so there's no term of x, yes, you should be able to factor it.
So he would not work for it?
What's that?
He wouldn't work?
No. No, this one's not going to work because we're not going to have any perfect squares here. So if I look at this problem, and the directions just said solve, and the method was up to me. Well, if I look at 5x squared plus 35, I have my x squared term. I don't have the middle term, bx, but I have my constant. That's the square root property. Those are the ones that the square root property is very quick for. You certainly, if the directions did not specify, could use another method to solve this. The only other method that would really work here would be the quadratic formula. You couldn't factor. It is factorable. It's really funny factorable. Not something I'd expect you to find. So if I look at this, I see I have the squared term. I see I have the constant term. I don't have the middle term. I don't have just the x. That's when to use the square root property. But in order to use the square root property, I have to have the setup. Setup is really important in Unit 4. Something squared equal to a number. Well, right now, everything's on the left side. So I've got to work on my setup before I can go to the square root part. So first thing, I'm going to move my number over because I want the number on the other side. So subtract 35. So I have 5x squared equals negative 35. Now, question. This actually goes back to 10.1. On the left side of the equation here, what is the squared attached to? The x? Well, what about the 5x? What about the 5? No. Without parentheses, it's just connected to the x. If I want to connect it to the 5, I'd have to do parentheses 5x squared. So far, I don't have my setup because this left side is not just something squared. The something squared is the x squared. It needs a coefficient of 1. That's the only way that you can take the square root is if the coefficient is 1. I guess if you had a perfect square, it would work. But because the squared here is only connected to the x, I've got to keep going to get that something squared all by itself. So I'm going to have to divide both sides by 5. So now I have x squared equals negative 7. There is my something squared. It's isolated. There's no coefficient other than 1. And on the right side, I have my number. That's your setup for the square root property. You have a question, Emily?
No, I was just wondering something after you did everything.
So
no solution since like
there is a solution. It's not there's no real answer to this problem. So how do I get rid of a squared? Square root. So I'm going to square root x squared, and if I square root the left side, I've got to square root the right side.
You put a plus minus in front of it?
Yep, every time.
Even though it's negative?
Yeah, the plus minus is outside of
Okay,
the
so it doesn't
radical.
apply to
Yep.
numbers. Got it.
Yep, so it doesn't matter what the number is. Yep, the plus minus will always go there because we're not told that x is positive. Which you might not have ever read it in chapter 10, but it was part of the directions. If you look at your test in the directions on the top, it says assume x is positive. We don't have that assumption here, so you got to do both principal and negative root. So on the left side, my x squared and square root there give me back x equals plus or minus the square root of negative 7. And now we're back to chapter 10, where in Unit 4, you're also going to be getting your yellow cards because all radicals have to be simplified. So all radicals still have to be simplified. So we're not going to leave a negative underneath the radical because we can simplify it. So again, it's not a real answer, but there is an answer here. So how might I simplify the square root of negative 7? Emily, what do you got? That's if you have a negative exponent. Negative under a radical. Square root of negative 1, so 10.7 right here. Yeah, and what's the square root of negative 1? Yeah, it's our imaginary unit, I. So we're going to have plus or minus I square root of 7. Now notice that the plus or minus was in front of the square root of negative 7. So the plus or minus should still be in front of anything you simplify. Occasionally I see people try to sneak the plus or minus between the I and the square root of 7. But it was out front of the whole thing, so just make sure it stays out front of the whole thing here. So my two answers, if I were to split it, would be plus I square root 7 and minus I square root of 7.
But you can just leave it like that, right?
You can. I'm just saying, if you're going to be prone to forgetting the plus or minus, break it up. If you can't break it up, then you forgot it. Or look at it and say, could I break that up? Yeah. The only time you can't leave it, as I pointed out before, is if the square root was perfect and you could add or subtract the two integer numbers. Questions? All right, C. C is a little bit more of where we're going on Wednesday. So I still see in my mess of C something squared. In this case, my something squared is this x plus 2. And I still see everything else here is just numbers. Square root property is going to be the quickest way to solve this, hands down. The long way to solve this, if your directions didn't specify, would be you'd have to write this twice, FOIL it, distribute a 3, get everything to one side, and then do something else to it. This is a lot quicker, trust me. So first thing, I need my setup. Setup for square root properties, something squared equal to a number. So is my something squared all by itself?
Yeah. No?
If yes, no, no, no.
Well, you shook your head no when we said yes, so I assume no.
What's on this side that's not part of this, what's being squared? 3. So you gotta move it over. And how am I gonna get rid of this 3? Divide it. It's being multiplied, yeah. If it's right out front like that, this case it's being multiplied. So our opposite is dividing. So I've got to divide both sides by 3. So now I have x plus 2 squared equals 54 divided by 3 is 18. So whatever that thing that's squared is. So both both B and C showed no coefficients, whether or not it's binomial or a monomial. No coefficients in front of whatever you're squaring. So this is my setup. Something squared on the left side, all by itself, and on the right side is my number. That's where your square root property comes in handy. Because how can I get rid of a squared? What's the opposite of squaring? Square rooting. Even though it's a binomial, if the whole thing is squared, if I square root the whole thing, those two are going to cancel each other out. And if I square root the left side, I've got to square root the right side and account for both the principal and negative root. Because we don't know if this x plus 2 is positive or negative. So on the left side, Square and square root will cancel each other out. So all that's left is my x plus 2 equals plus or minus the square root of 18. Now before, when we took the square root, we were done because we just had x on the left. This time I don't just have x on the left. So I've got to finish solving it. Now think about, forget the fact that there's a plus or minus and that this is a square root. If this was x plus 2 equal to a number, how would you finish solving that for x? Subtract 2. Now we're going to do the same thing, except we don't usually tag the 2 on the end. So the notation is that whatever has the plus or minus should be at the end. So I say sandwich or wedge this negative 2 in front of the plus or minus. So what your answer looks like is x equals negative 2 plus or minus the square root of 18. So if you move that term over through addition or subtraction, sandwich it in front of the plus or minus. Don't tag it on the end. Am I ready to box this answer?
Yes.
Ashley says the square root of 18 can be simplified. Absolutely. How could I break up the square root of 18? 9 and 2. Square root of 9 times the square root of 2, which gives me 3 square root 2. So x equals negative 2 plus or minus 3 square root 2. And you will have your yellow cards, so you'll have the perfect squares tables, but you got to simplify all radicals. And if you were to break this up into two answers, you wanted to see your two answers. The first one is negative 2, and then when you come to the plus or minus, you include the plus, usually the first time, plus 3 square root 2. And then you do it again, negative 2, and where the plus or minus is, you write the minus 3 square root 2. This one would be another acceptable one to leave it stacked. You could leave the plus or minus. But if you want to see your two answers, you can break it up there. Questions, Daniel?
Is this the only way to solve this problem?
No. The only other way, let me think. Quadratic formula would work. Quadratic formula works for everything. But sometimes I will say you have to use this method because I need to see that you know all the methods. And your final exam is the same way. Whoever writes your final exam specifies methods. The other way to do this would be to take this x plus 2 squared, write it twice, FOIL it, distribute 3, combine your like terms somewhere in there, move the 54 over, and then go through the quadratic formula. It works. You get the same answer. It'll just be a lot more work to get there. Any other questions? All right, D. I have 5x minus 1 squared equals 7. Is this set up for the square root property, or is there anything I have to fix ahead of time? I've got a tentative setup. I saw a head shake no. Setup. Robert says no. What do you want to fix, Robert? Ken says no. You don't know. What would you fix, Ken? What would you change?
Well, you got 5 times that.
But where's the 5? Inside the squared. So the something squared is this whole thing right here. So x squared. Highest power of x is x squared. Well, I mean, there can't be x cubed. There can't be. It doesn't have to be 1x squared. But there can't be x to the 3rd power, or x to the 4th power, or x to the 5th power. And since the 5 is in the parentheses, it's part of my something squared. So that's okay. So what we're looking for is that there's no coefficient outside of the something squared, and that there's nothing added or subtracted outside of the something squared. But right here, that's a good something squared. Right side, just a number. So you do not have to write this twice, FOIL it, do all sorts of things, because how can we get rid of the squared? Square root. So I'm going to take the square root of 5x minus 1 squared equal to plus or minus, got to account for both of those, the square root of 7. on the left side, having both the squared and square root will take each other out. So all that's left is 5x minus 1 equals plus or minus the square root of 7. And then ignore the fact that this is a square root, that there's a plus or minus. If I were looking at the left side that has the x and just regularly solving that, what's the first thing you would do? Add 1. And when you add to the other side where you have the plus or minus, sandwich it in front of the plus or minus. So now we're down to 5x equals 1 plus or minus the square root of 7. Now, even after we did that, we didn't get down to just x. So what's the last thing that you would do to solve for x? Divide by 5. So that hasn't changed. Now, there's a couple of different ways you can do that to the right side. It's okay to do the one big divide by 5 as long as you don't have an imaginary root. Because the directions say if it's imaginary, you have to write it in the form a plus bi, which we learned in the end of Chapter 10, you have to have the two separate fractions. So the other way you could write this is you could do 1/5 plus the square root of 7 over 5, because that'll cover you for any imaginary roots you might get. The other advantage to this right here is that it's easier to simplify this fraction individually, this fraction individually. And on Friday, we'll talk a lot about how to simplify the 3-term fractions, which we actually did back in Unit 2, where you just need a GCF to all 3 terms.
So I can leave it like that, 1 plus or minus, or just something like that?
As long as it's real. If it's not real, you have to break it up. If the radical has an I with it, at the end of Chapter 10, and the directions say you have to write in the form a plus bi, if you leave one big fraction and you have an I, it's not in the proper format of a complex number. So it's okay to leave it as 1 as long as you can't simplify the whole fraction and it's not imaginary. And again, you could also break that up into your 2 answers. You could do 1 plus the square root of 7 over 5 and 1 minus the square root of 7 over 5. Or if you're doing separates, you would do plus for the first one and minus. So, oops, not comma, minus. So really there are 4 answers for this one that I would take. Any of those 4 will do. You just got to be careful if you leave the one compact fraction. Again, you can't do it if there's imaginaries. And if this can be simplified, you've got to go back to simplifying 3-term fractions, which we'll go over again on Friday. So any questions about our square root property? And what actually is going to happen on Wednesday is this is going to be the last step to some longer problems. Questions? So what we're about to do now is the first step to those problems. We're going to do it separately today, and then on Wednesday, we're going to put it together. So the homework is important that you understand the 2 separate components. So on Wednesday, when we put them together, it's a little bit easier. So then it's just, okay, I do the first part, then the second part. We've already done all of it. So what we're going to do now is we're going to complete the square. And what completing the square means, it says somewhere up here. Okay, so determine the constant that should be added to the binomial so that it becomes a perfect square trinomial. So what a perfect square trinomial means is that when I factor my trinomial, so we're going back to Unit 1, when I factor my trinomial, I get the same factor twice. That's a perfect square trinomial. So when I factor it, I get the same factor twice. So what you're going to be given is you're going to be given the first 2 terms of a trinomial. And you need to find C. You need to find the number on the end here. That when I go back and factor the whole thing, I get the same factor twice. So how do we find C? Well, there's 2 steps. These 2 steps don't change. These 2 steps are always the same. First thing is we're going to go all based on B. So if I look at x squared plus 8x, what the directions are asking you for is the constant that that when I write it on the end, and then I look at the whole problem, I factor it and I get the same factor twice. So what we want to do is start with b. What's b for this problem? 8. So remember we had this form, maybe we should write this up here. ax squared plus bx plus c. We saw it a whole bunch when we were factoring. So b in this problem is the 8. So the two things we want to do to b. The first thing you want to do to b is take it and divide it by 2. So you take 8 and divide it by 2, and I get 4. And then the second thing you want to do is take that answer and square it. So we're creating a perfect square trinomial. We're completing the square. You take whatever half of b is, and you square it. So half of b is 4. So what we're really doing is we're taking half of b and squaring it. So we're taking our 4 and squaring it, which gives us 16. So take whatever b is, divide that by 2, square it. So this is really the number that we're looking for kind of as a whole. It's b over 2 squared. Another note about Unit 4 is that there are formulas to memorize. There are going to be formulas to memorize. So if you work on that summary sheet as we go along for your extra credit on your test, good thing to note down on different parts would be what formulas to use. What's that? So the number that we'd fill in for C here, 16. So now let's think about factoring this. Emily. This is always in the formula. It's always divided by 2. So you'll always split it in half and then square that result.
How do you know when the number you're about to add to the problem is a positive?
It's always positive. It's always positive because the second step is to take your answer and square it, which means multiply the number by itself. So if I have 2 negatives, I multiply them, I get a positive. If I have 2 positives, I multiply them, I get a positive. So this side right here will always be plus. So the sign in front of whatever constant you're adding here will always be plus. Now, if this works, when I factor this, I should get the same factor twice. So these will always be the shortcut method. So I need 2 numbers that multiply to 16 and add to 8. 2 numbers that multiply to 16 and add to 8. 4 and 4. And if you don't say the same number twice, then your perfect square trinomial is not a perfect square trinomial. So if I go to factor this, my factors are x plus 4, x plus 4, or how else could I write that? X plus 4 squared. And that's what we're really looking for, is that you get your binomial squared. Because what's going to happen on Wednesday is all of this work is just going for the left side of the equation. And what we're getting to is we're going to be setting up problems so they look like this. They look like a binomial squared equal to a number. So we're going to create this factor squared on the left so that we can use the square root property when it comes to Wednesday. So the way your book writes the answer is they write, the first thing is determine the constant, so they'll write 16, semicolon. Then it says write the trinomial, so then they're going to write x squared plus 8x plus 16, semicolon, and then they're going to write x plus 4 squared. What I want to see is I just need to see what number you filled in the blank with, and then whatever your binomial squared is. Those are the 2 parts of the answer I really care about. So if I look, I'm going over to C. I didn't label these correctly. X squared minus 6x. So the first thing it says is determine the constant that should be added so that it becomes a perfect square trinomial. So I need to find what my C should be so that when I factor this, I get the same factor twice. So there's 2 steps to that. The first step is we need B. We need to know what B is. So B in this problem is negative 6. And you got to take the sign there. So we know what B is. B equals negative 6. So we're going to take it and first divide it by 2. That's just one of the steps, is it's always divide by 2. And that gives us negative 3. And the second thing we need to do with that number, square it. Which gives us a positive 9. And that, whatever you get after you square it should always be positive, because you're multiplying the number by itself. So the number that completes the square here is 9. Ken?
What's your answer for the other one?
I said I need to see the 16 and the x plus 4 squared. Yes. So if this worked out, I should be able to factor the trinomial now and get the same factor twice. So I need a pair of numbers that multiplies to a positive 9 and adds to a negative 6. Emily, what do you got? X minus 3, x minus 3. And how else could you write that? Perfect. X minus 3 squared. So this is what I'm looking for. I want to see your trinomial, what you factored, and then I want to see your factors. And if you want to write it twice first, that's okay, but what we're really looking for is the fact that you can write it as a factor squared. That's what makes it a perfect square trinomial. So if we go back now to B, first thing I need to do is find that number that goes on the end here. There's 2 steps to doing that. The first step is that you take whatever B is, which is negative 2, divide it by 2. So I get a negative 1. So that's step 1, divide by 2. Step 2, take that answer. We're completing the square. We want a perfect square trinomial. Square it. Negative 1 squared is positive 1. So the number that completes the square, that gives me the perfect square trinomial, is a positive 1. And then this is only worked out is if I factor that trinomial and I get the same factor twice. So I'm looking for 2 numbers that multiply to positive 1 and add to negative 2. Negative 1, negative 1. So I can write my factor as x minus 1 squared, because my factors would be x minus 1, x minus 1. Questions? All right, so for D, we're looking for that number, that constant C, that makes this a perfect square trinomial. So first thing I need to do is take B and divide it by 2. So B is 9. I'm going to divide it by 2. But 9's not even. And you don't want to use decimal approximations here because we want exact answers. So that's going to include simplifying square roots later on. So 9 halves, I'm going to leave as 9 halves. It's okay to have a fraction. So first step is divide by 2. So I can represent my division by 2 by just writing 9 over 2. Second step is that I need to take that 9 over 2 and square it. How do you square 9 over 2? There's actually a couple different ways. Multiply it by itself. Simplest way. I mean, think about what's 4 squared? 16. How do you get it? 4 times 4. So squared just means take whatever you're working with and multiply it by itself. So that's going to be 81 over 4. So the number that completes the square is 81 over 4.
Can you simplify and then multiply it on the line?
Only if you had a common factor for 81 and 4. So next question. How are we going to factor x squared plus 9x plus 81 over 4? So I need 2 numbers that multiply to 81 over 4 and add to 9. So let's look at the other problems. There's a pattern here that makes these really, really easy. So our first problem, we factored and we got x plus 4 squared. Notice the only thing that's changing in all of these problems is the number that goes with x. Well, where did I first see 4 in this problem? B over 2. Not the squared. When I squared it, I got 16. But when I did b over 2, 8 divided by 2, I got 4. Positive 4. What ended up in my factor? Positive 4. Next one, I did my b over 2. I did negative 6 divided by 2, and what did I get? Negative 3. And what ended up over in my factor? Negative 3. In this next problem, I did b over 2. Negative 2 over 2 gave me negative 1. And sure enough, the number that landed in my factor, negative 1. So when I go here, it looks ugly because I've got this fraction, but all you really need is x and then whatever your b over 2 is. And that's squared. Now, you do have to be very careful that you take the signs. It's not always plus. I mean, we write it generically as plus, but if you have a negative number, plus and negative is the same as subtracting. So that's why it's important to keep that sign with b, because this number here always ends up back in your factor. So when I'm looking at this problem here, I'm thinking, how am I going to factor that? Just go back to b over 2. That's the number that goes into your factor. Now, it can get a little ugly from there if you, for example, have to then take the square root and maybe add that fraction over to the other side. But we'll save all of that fun for Wednesday. So that's it for us today.